All right, yeah, so thanks everybody for tuning in, and I hope you enjoy this presentation on how we can save energy this summer. So a little bit about me. I work at Sapien. It's a company that a friend and I started up a few years ago now. We were both in uni, we were both studying engineering, and we're both very passionate about sustainability and energy efficiency, and we kind of got together and had a brainstorm about how we can get involved in this space. And draught proofing was kind of had the lowest barrier to entry in terms of offering that as a service. And so that's kind of how Sapien was born, and we've built on that to kind of offer other options and services for making homes more energy efficient and more comfortable. So that's how I sort of got involved in this space. So today we're going to cover a few different things. We're going to touch on how weather has been changing in Victoria and how the climate's been changing. We're going to do an overview of the energy efficient home retrofit journey. So all of the steps in the journey of making a home much more energy efficient. We'll touch on indoor air quality as well, which is becoming a more prevalent issue with bushfire events or thunderstorm asthma events. And then at the end, we'll go through some draft proofing DIY tips and tricks, so stuff that we've learned over the years that we think are pretty helpful that we can pass on and we're happy to share. And then we'll just do a bit of a Q&A, any questions you have about any of the topics that we've covered. So here's a couple of charts that I pulled off the BOM website that look at how the temperature in summer has changed over the years. So on the left, we've got the average temperature anomaly, and that black line is the rolling average. And as we can see, it's steadily climbing upwards. So the average temperature over summer is getting a fair bit warmer. And then over on the right, we have the maximum temperature anomaly. And again, that is trending quite sharply upwards. And our hottest days in summer are getting hotter than they ever were before. So we're getting more extreme weather events. Our heat waves are getting hotter. And this also can lead to more severe bushfire seasons. And so these hotter summers is a great idea to start thinking about how we can make our homes more energy efficient and more comfortable as we adapt. So what's in the energy efficient home retrofit journey? There's sort of 8 key steps. It starts off with more kind of passive solutions like draft proofing, replacing lighting, high quality insulation and windows. And then it kind of leads on to efficient appliances, cooking processes, what heating and cooling system we're going to use, hot water. And then finally, we've got solar power to offset what energy is remaining. So the order isn't fixed by any means, but that is a rough guide. If you were going to follow an order, you probably do it in this manner because the benefits from the earlier items feed in to other items down the track. So your solar power system might be smaller, or your heating and cooling system isn't going to have to work as hard if you've got a really good quality insulation and draft proofing that's taken place. So the ones that are bolded there are the ones we're going to kind of dive into in this session. So moving on, why would we begin the energy retrofit journey? There's a few really good reasons. It was interesting when we first started out, we thought that the biggest reason would be people wanted to reduce their energy bills, and that's how we kind of framed to the business. But what we're actually finding is the number one reason we were getting called out to people's houses is they wanted to improve their thermal comfort. So I thought that was an interesting tidbit. So improving thermal comfort is a really big reason for beginning the energy retrofit journey, especially now that we're all spending a lot more time at home, or at least have been for many months now. The second really good reason is as we use less energy, our energy bills are going to come down. So we're going to save money, which is always great. And the third really great reason is it's going to reduce our carbon footprint, which is obviously something that's very important. So the first step in that journey is draft proofing. Air leakage can account for 15 to 25% of winter heat loss, and it's also a significant loss of our cooling in summer. So it is a really good place to start. And it's kind of one of the lowest barrier to entry. Is it something you can do for yourself or get a professional to do? It's not that expensive and the benefits are long lasting. There are a couple of other kind of happy side effects of getting draft proofing done. So often it'll improve acoustic separation. We find if a house borders a busy road or a sports oval, then after we've draft proof it, there's a sort of noticeable decrease on the noise ingress. It's also going to reduce the ingress of dust and bugs. And we're also going to kind of slow down the rate that outside air can enter the home. which can become important if we do have a high pollution event like a bushfire or thunderstorm asthma. So we'll go into this a little bit more at the end when we go through our DIY tips and tricks, but that's our sort of overview of draft proofing to begin with. So the next step in the energy efficient home retrofit journey is lighting. And there's a reason that this is sort of so early on in the journey, because it does have a few run-on effects that we'll talk about. So first and foremost, halogen downlights use a ton of energy. So if we can replace them with LEDs, which draw a lot less power, then that's already a huge win. But there are a couple of other reasons that also make halogen downlights quite problematic. So because of the heat they generate, these fittings are typically ventilated. So that's another source of draft between our ceiling space and our living area. In summer, our ceiling cavities can get very, very hot. They're not airtight, generally speaking. So we do want to keep that separation, and we can't do that if we have halogen downlights in place. The other really big issue is they have clearance requirements around them that must be free from insulation to reduce the risk of fire hazards. Because again, these fittings can get quite hot. And I've just pulled out a little image there on the right from the standard that shows these clearance requirements for halogen downlights. This is quite problematic because a reduction in insulation coverage disproportionately affects the performance of that insulation. So a 10% loss of insulation coverage isn't going to decrease the performance by 10%. You're more looking at 30 to 50% reduction in performance. So it's quite significant, and we really want to get good insulation coverage and reduce the possibility of thermal bridging. You can see in the image on the left there, I've just done a little thermal imaging camera snap from one of our audits. And you can see the big patch around the downlight where a whole panel of insulation is just completely missing. And so again, that just feeds into that issue with coverage, and we'll get a lot of heat coming into the home through that if we don't have good quality, good coverage insulation. So what can we do for renters? It's always a good idea to replace the globe with an LED alternative, but this doesn't solve the other two issues that come with downlights, them being ventilated, or these clearance requirements still must be adhered to in case someone changes it back to a halogen globe down the road. So for homeowners, we recommend don't just stop at replacing the globe, but replace it with a fully sealed LED fitting. So there are items out on the market where it's airtight, so you're not getting that draft, and they can either with a cover or some without, you can insulate right up on top of them because they don't generate nearly as much heat, so that fire hazard isn't there. And then you're getting much more out of your insulation coverage as well. So the next step in the journey is insulation. Once we've dealt with the downlight issue, we can put insulation in everywhere. So we've already talked about the kind of disproportionate effect that having gaps in insulation coverage has on its performance. You can see in the top right there, there's another thermal imaging snap showing really patchy coverage. And unfortunately, this is quite typical of the homes that we get called out to, at least. And I think generally the quality of homes in Victoria and Australia in terms of insulation coverage is not particularly high. So during summer, we're getting 25% to 35% of our heat gain through our ceiling. So that's a really important place to look at. 15 to 25% through the walls and 10 to 20% through the floor. So what can we do about it? For the ceilings, we recommend R5 bats. So the R value is a metric for the capacity of that material to resist heat transfer. So the higher the R value, the higher the resistance of that material. So the better it will reduce heat coming into the home or out of the home, depending on what season. So R5 is slightly above the kind of minimum code compliance. It's a little bit higher than that. And generally the higher the R value, the better, but you do start to get diminishing returns. So R5 is kind of a happy kind of compromise where you're getting a lot of bang for your buck. If you wanted to go more than that, you could, but R5 is typically pretty good quality. For walls, these can be quite challenging to retrofit, but there are solutions on the market for blow-in wall insulation where you're cutting sort of a 20 cent to 50 cent size hole in the weatherboard or the brick or the plaster and just blowing insulation in. So that's more or less one of the only ways that blow-in wall, or that wall insulation can be retroactively put in without kind of tearing everything down to put some bats in. There's a couple of cool little tricks to tell if you have wall insulation or not. One is if you do go out and buy a little thermal imaging camera, and you can get one for kind of $200 to $300 now that work with your phone. That can be a good way to look for patchy insulation in the wall. Sometimes this doesn't work that well if the whole wall is devoid of insulation, then it will still just kind of show up as a blanket color. It's really good at picking up patchiness, but not necessarily a total loss of coverage. The other thing you can do is pull one of your kind of power outlet covers off the wall, and obviously be very careful of any cables and that kind of thing. But if you can just put your hand in the cavity there and feel around from any insulation, and if it's not there, then generally there's probably some room for improvement. For underfloor, we recommend R2.5 polyester rolls. These are a really good product, and the way they're made is they fit nicely between the standard joists underneath a home, and they can just be staple gunned into the joists. So it's a really nice, snug fit with good quality insulation. The reason we kind of steer towards this rather than other products is mainly because of the way it's fixed. So often you'll see kind of bats that are strapped under or held there kind of with chicken wire. And if you have the insulation pulling away from the underside of the floorboards, you're losing a bit of performance and potentially making a little home for vermin and that kind of thing. So this is generally a really solid product that we recommend. You can see an example of an installation there in the bottom right. All right, moving on from insulation, we've got windows. So once we've kind of dealt with the first 3 steps of the home retrofit journey, windows are really going to be your largest source of heat gain in summer and heat loss in winter. So blinds and blockout curtains are always a great idea and something renters can look at as well. When we're thinking about blinds, I've got an image on the left there that shows a kind of honeycomb blind. These are really nice because you're blocking the sunlight from entering the home and heating it up in summer, but you're also getting that still air gap as those blinds open and that honeycomb shape opens up. You're getting a nice still air gap, which is reducing the ability for heat to conduct into the home. When we're looking at installing blinds, the other thing we want to consider is it snug to the window frame? So if you've got big gaps at the top or bottom or at the sides, while it's still better than nothing, we're not getting the same benefit we would with a really snugly fitted set of blinds. It's actually going to create that still air gap. That's really what we want to reduce heat transfer into the home. So on those hot days, we want to block out the sun where it is, so northwesterly or easterly, depending on the time of day. Another option is window films, which can be put onto glazing. So there's things like low emissivity films, which can be put on, which will reflect a good portion of the sun. These are generally a pretty good idea for hot weather applications. A couple of things you would want to be mindful of is if it's creating a bit of glare that might disrupt your neighbor. The other issue is in winter, it's actually going to reduce the amount of light that comes into the home that you would want to come in and heat the home up. So the value proposition isn't always there because sometimes these films can only be seasonally beneficial. So there are a couple of other different options on the market as well that improve how much light passes through the window and that kind of thing. But yeah, often the value for money sometimes isn't quite there with window films. But it's just important to make sure you do your research and you do your homework when you're looking at a product and get something that's going to benefit the home all year round, rather than help you in some seasons and hurt you in others. So next on the list is secondary glazing. We've all heard of double glazing, but often double glazing comes with a really high price point, which can price a lot of people out. So secondary glazing is a cool alternative that we can apply to existing homes. There's a couple of different suppliers on the market of this, and essentially what secondary glazing is, we get a little spacer and then an acrylic pane which goes on the back of the existing glazing. So you're getting the effect of that still air gap and a second layer of glazing or acrylic without the kind of really high price point of actually having to replace the whole glazing unit. So that's just a nifty little option and something to keep an eye out for if you are looking at trying to improve on the glazing performance you've got in the home. If you are looking at replacing the whole unit or the whole window frame, the material of the frame is something that's really important. So we generally want to go for materials that have very low conduction, like wood or plastic. But if you do want a kind of aluminium finish or a metallic finish, then it's important to get a frame that's thermally broken. So it would be aluminium finish with a wooden piece on the inside or a plastic piece on the inside, because otherwise you're getting a ton of conduction. Often that means condensation in winter as well. So we really want high performing frames as well as high performing glazing. On the right there, I've just got a little snapshot that I took at a sustainability workshop. So that's a little triple glazed unit that's very airtight and a high quality frame. Potentially a bit of overkill for Melbourne's climate, but certainly can't hurt. And I just thought I'd share it because I thought it was a pretty cool product that I saw at this workshop, an example of the kind of top tier options that are available. So external shading, very important in summer. A few different options. A really good one is planting deciduous plants. So these are plants that are nice and leafy in summer, so provide us that shading that we want, and then they'll shed their leaves over the winter and let the sun in so that we can heat the home up in winter. So there's a good little example of that sort of in the top right. So these deciduous plants can help us in summer through three sort of separate mechanics. The most significant one is probably the shade that it provides. Secondly, we've got evapotranspiration. So as water and moisture from the plants evaporates, that reduces the air temperature around them, which is great for summer. And also increased vegetation is going to reduce wind speed. So if we've got a really hot northerly and we've got some vegetation to slow that down, then it's going to heat up the house more slowly. So it can help in that sense as well. For north-facing windows, it's a really good opportunity for fixed horizontal shading. So something like eaves or other forms of horizontal shading that just come out from the window. So in summer, we've got a really high sun angle. And so that shading can block the summer sun from coming in. But then in winter, when the sun angle is much lower, we can allow it to pass through. So it's a great passive solution for shading for north-facing windows, where we can capitalize on the varying sun angles depending on the time of year. So there's a good little image of that in the bottom right. These images are pulled from Your Home, by the way, which is a free government resource on making your home very energy efficient. I definitely recommend checking it out. We've also got slats. You can do the same design principles with slatted shading. They're in that middle image where we're letting that winter sun in and we're blocking the summer sun based on the angle and spacing of those slats. For east and west facing windows, because we've got the sunrise and the sunset, we basically need to have adjustable vertical shading. So something that we can adjust depending on the time of day. And so that pretty much covers us off for shading. So next is cooling. So this is a big one. What's the best way to cool our home actively? Heating and cooling accounts for about 40% of household energy use. So that's a very big chunk of the energy pie. The higher we can tolerate our air conditioning set point, the less energy our system's going to use. So typically somewhere between 24 and 27, depending on how hot it is a fairly fair compromise between comfort and energy use of the system. Our first port of call should always be fans, as they are by far the lowest energy option. You can always chuck a little bowl of ice in front of it out of the freezer to get a little bit more juice out of the fan, which is a nice option. So range of different active cooling options. Number one, we've got fans. We've also got air source heat pumps, or our classic reverse cycle air conditioning, and we'll jump into the different options we have there, as it is a very common one. We've also got evaporative cooling, ground source heat pumps, and geothermal. So these are some of the main active cooling options you see out there that we'll discuss here. So fans, this is the lowest energy option, also the least effective, unfortunately, especially in extreme heat. So fans will cool you down, but they won't cool the room down. For renters, portable fans are a great idea. Typically, the smaller they are, the less energy they use. And there are even cute little portable kind of USB powered desk fans you can just plug in, and they just draw a couple of watts. And it's a neat little way to stay a bit more comfortable before we go on to cranking on the AC. I also wanted to touch on these air multipliers, or these kind of Dyson bladeless fans that we see out there. So aesthetically, these fans look really great. The desired effect, or the kind of output we're getting from these fans, and they're energy efficient. Typically, we can get that at a much lower price point. So it just depends what you're after. If you're just looking for value for money and an effective option, probably maybe this isn't for you, but some people think they look really cool, and there's nothing wrong with that. So you can go right ahead. But that the price premium really is for the aesthetics rather than the performance, based on the information that's out there. So a more permanent option, we've got ceiling fans. Typically, a DC fan will use less energy than AC fans, so something to look out for. A cool way to kind of compare different fan options out there on the market is to look at the amount of energy drawn per unit of air moved. So we've got our watts per meter cubed per hour of air movement. So if you've got two different fans with different wattages and different air movements, you can take the wattage and divide it by that flow rate. And the lower that number is, or the lower of the two, is probably the more efficient fan. So it's a nice little way to kind of test apples and apples, because it's a bit hard to know how good it is if they're kind of two different flow rates and two different wattages. So that's just a nice way to be able to compare options like for like to get the most efficient result. This can make a big difference. High efficiency fans are sometimes drawing as little as 12 watts, whereas the lower efficiency alternatives can go up to 100 watts. So over the lifetime of usage, that can make a difference. Also, most fans will have this option, but make sure you get one that's reversible, because then you can also use it in winter and it's going to push down warm air that's accumulated at ceiling level. So you can get good use out of it in summer and winter. So next on the list is air source heat pumps. This is probably one of the most common types of air conditioning in Victoria. And it's just our typical sort of reverse cycle split system or central unit. Now, another thing to note here is, so the outdoor unit that we have for these reverse cycle air conditioning units, in summer when we want cooling, we really want that to be in the shade so that the unit isn't overheating and struggling to reject that heat. But then in winter, we do want it to be in the sun because it's trying to absorb heat and move it inside the home. So this is another good opportunity if you are installing one of these to think about where you're going to place it. And it's an opportunity for well-designed north-facing shading if we've got that option, or deciduous plants again. So what are the different types? We've got individual split systems. So this is your classic one indoor unit for every outdoor unit. This is typically the highest efficiency alternative. They're more efficient than the central systems, generally because we're individually controlling portions of the home rather than cooling down or heating up the entire home. And central systems also come with a few other losses that we'll dive into when we get to that. So this is typically the best option. We've also got multi-head split. So this is multiple indoor units that are connected to a single outdoor unit. So typically it's a bit cheaper and it's a bit more space efficient if you don't have many spots to put the outdoor unit, but it is a bit less efficient than our kind of individual split system alternative. So something to consider there. Then we've got our ducted systems, or our central systems. So it's a single big indoor unit that's ducted to multiple indoor spaces. The use of a central system or a ducted system does introduce a couple of extra inefficiencies and risks. So we're going to be using a bit more fan energy to actually push air through a ducted system to different rooms in the home. We're also going to get a bit of ducting heat loss from the ducting running through an unconditioned space in the ceiling. And we can also get a bit of air leakage if it's not a very high quality installation. There can be some air leakage through the ductwork, which is not ideal, and an additional source of draft. So these are some of the kind of inefficiencies that can come about from this kind of system. And as a result, they typically are less efficient to the individual split system alternatives. The other option, which is good for renters, is a little portable air conditioner. So these are just kind of little mobile units you can put in whatever room you're in, and they typically come with a flexible duct that you can attach to a window to reject heat, similar to this little graphic on the right. They usually have something to sort of block the window out so you don't just have a big, open window with hot air coming in, and it'll reject some heat out there. Again, typically not as efficient as our other alternatives, but if you're renting and you need some kind of active cooling, it's not a bad option. So then we've got evaporative cooling. Besides from just having a fan, this is probably one of the lowest energy active cooling options. So certainly when compared to our reverse cycle air conditioning, evap cooling typically for our climate uses a lot less energy. This does kind of flip over once we start to get a very efficient home. So if we have a home with all of the passive principles applied, so it's nice and airtight, it's got really good quality insulation, and we have a high efficiency air sourced heat pump or reverse cycle aircon, then it starts to tip, and actually the reverse cycle AC is going to use less energy than the evaporative cooling. This is because if we have a really efficient home and we've got that air source heat pump, it's just recirculating cool air inside the home, and it doesn't have a whole bunch of heat coming in. Whereas our evap cooling, because we need to open up the house and bring in outside air, that energy use is kind of set. So the better the house is and the better performing the heat pump, we can reach a point where it becomes more efficient. For your average Australian home, evaporative cooling is probably going to be one of the most efficient options. It does have a few limitations, so they don't work very effectively if the humidity is high. Generally in Melbourne summer, not a big issue, but again, we do get those muggy days every once in a while and they're not going to work that well. It does require a constant water source, which is something else to consider. And it also comes with sort of all of the problems that a ducted central air conditioning system has. So there's possible air leakage. The air leakage risk from evaporative cooling would actually be higher than a central reverse cycle air conditioner because it's bringing in outdoor air. And again, kind of heat losses and that kind of thing through the ducting. So there's a few different things to weigh up there, and also it's cooling only, whereas a reverse cycle heat pump is heating and cooling. There are portable options available again for renters who don't have evaporative cooling installed, so that can be a good little option. The last on the list that I just wanted to touch on is ground source heat pumps or geothermal. These do work a little bit differently to each other, but essentially they rely on constant ground temperatures once you go deep enough and capitalizing on that as a heat source or heat sink. So these can reach very high efficiencies. Often they can be more efficient than our sort of split systems, our reverse cycle heat pumps, but this does come at a very high cost and a lot of additional complexity. So typically, this isn't the most practical option out there, but I just wanted to raise it. If money's no object, then potentially it could be something that people want to look at. But yeah, typically that high cost and complexity rules it out as a viable option compared to evap cooling or reverse cycle air conditioning. All right, and solar power. So this is the final step in the sort of journey after we've done all of these options. Now we want to offset the energy that we're still using. So the price of rooftop solar has been coming down for years and years, which is great. It's becoming much more financially viable. Most sources around today quote a payback period of about 5 years for a 5 kilowatt system in Melbourne. If we have kind of followed the energy retrofit journey up to this point, a 5 kilowatt system can effectively offset all of our energy use and make our home energy neutral or even energy positive. We're generating more electricity than we're consuming. Every year there's usually a sustainable house day in Melbourne, and it's a great opportunity to check out some of these homes that people have already put together that are very efficient, and many of them are energy positive, and it's really cool to see. If you're renting and there is no solar system, so it's not an option, there are now more green energy power supply options coming onto the market, which is a great way to get your energy from a renewable energy source. So little option there. The next thing I wanted to talk about was indoor air quality. So as our climate is changing and bushfire events are becoming more extreme and possibly more common, we need to start considering how we manage that when the air quality is very poor. So why do we care about air quality? There's a ton of literature out there that shows the negative effects of being exposed to fine particulate matter. There's a few kind of scary stats that I've pulled in here. So for every 10 microgram per cubic meter increase in PM 2.5 particle concentrations over long-term exposure, we have a increase in all-cause mortality of about 6 to 7%. So that's pretty serious. And then there are also studies showing that short-term exposure also increases all-cause mortality with 0.6 to 1.5% increase in daily deaths as a result of an increase of 10 micrograms per cubic meter, again in PM 2.5 particle concentration. So to put that into a bit of context, I've pulled the this from the Victoria EPA on the right there, where we show so fewer than 27 micrograms per cubic meter of PM 2.5 particle concentrations is considered good air quality, and greater than 370 is considered hazardous. During our January bushfire event this year, our concentrations peaked at over 400 micrograms per cubic meter in Melbourne. So gives you an indication of kind of that for every 10 microgram per cubic meter increment, it can actually jump up very seriously. So this is why we care about indoor air quality. What are the sources of indoor air pollution? Probably the highest risk one is a bushfire event, or perhaps you live near a few people that have sort of wood fire heaters, and they're going to reduce the air quality in the vicinity. Indoor cooking processes, smoking indoors, or if you live near a busy road, vehicle exhaust. So what can we do about it? Draught proofing is a good alternative. There's not a ton of literature showing the direct benefits of this, but logically, if we're slowing down the air change rate of the home, or the rate that outside air is going to come into the home when the outdoor air is not of a high quality, then that's going to help our indoor air quality in a high pollution event. Running your air conditioner. So if you do have a central system, make sure you're cleaning the filters regularly, but when you're running that, It's running the air in the home through your filters. Typically, the filters in your standard air conditioning system aren't going to be great at removing smoke particles. They're just kind of there to protect the coil, but it is better than nothing. And we'll talk about what we can actually do about that in a couple of slides. If you are cooking inside, I know some people hate running the kitchen exhaust for some reason because it's a bit noisy or annoying, but it is probably a good idea to run it so you're not getting cooking process particles building up in the home. Our other options are portable air cleaners, which we'll have a chat about, and we can also upgrade our central air system filter. So portable air cleaners, these are a great option. They can reduce indoor airborne particle concentrations by up to 85%. Most of your options out there, or at least any of your kind of decent options, will have a HEPA filter or a high efficiency particulate air filter, but you do want to make sure it comes with that. This is kind of the highest grade filtration we can get, and it's great for these really small particles like smoke. Make sure you select one that's suitable for the space you want to use it in. So often they'll come with a sort of square meters that they're appropriate for dealing with. And if you can even get one that's bigger than that's like rated for a larger room than the one you're using in, then it's going to be even more effective. Obviously, the operating hours limits its effectiveness. So the longer we run this and the higher we have the fan speed on, the more filtration we're going to get. So if there is a pollution event and you're in a room, we would recommend running it the entire time that room is occupied. There's also a strong body of literature showing the health benefits of using these kind of things and their effectiveness at reducing air pollution. One of the only downsides, other than the cost, is they can be a little bit noisy, which can be annoying. So you might want to test it before you buy it, depending on the model. Our other option, if we already have a central air system, is we could upgrade the filters on our central air conditioning system. So most homes have pretty low performing filters, sort of around G1, G2. The EPA, this is the US EPA, but it does carry over. They've done some studies on this, and they recommend a filter with a performance rating of F6 or F7. We can put an even more highly rated filter in, like a HEPA filter. So again, the F6 and F7 isn't as good as a HEPA filter that we see on our portable air filters, but this can impact the ability of our central system to actually cool down or heat up the home because our fan is having to work extra hard to pull air through that filter. So if you want to go higher than F6 or F7, you might need to ring up the supplier or the manufacturer and work out what your system can actually cope with. But that F6, F7 performance is kind of a happy compromise between the performance of your system and the ability to remove pollutants in the home. Again, our operating hours limit effectiveness, and there isn't as much research, unfortunately, on the health benefits of improving our central systems filtration, but logically, again, it does make sense that if we've put in a higher quality filter that's better able to remove smoke particles, then we're going to see a little bit of benefit from that when we're running it to improve indoor air quality. All right, and what can renters do? So a lot of these things renters can do. A lot of these things may be more tailored towards homeowners, but there are a bunch of new changes coming in March about what modifications renters can do without the permission of the landlord, or kind of things that landlords can't reasonably refuse. And so that's likely to cover things like simple energy efficiency upgrades. And we were talking earlier, there also was just an announcement by Daniel Andrews about improving the energy efficiency of rental properties. So I'm yet to kind of dive into that or see what further info comes, but it's something to keep an eye out for and see what else is going to be there for renters to make their homes more energy efficient. Then finally, I just wanted to run through a few draft proofing tips and tricks and things to look out for. So how do you find drafts in your home? When we're doing it, we typically do a draft proofing audit, and we'll bring a blower door, which kind of blocks out the front door, and it's got a big fan which will suck air out of the house. And then we go around the house and we can feel where that air is being made up, and that helps us find the worst sources of air leakage. You probably don't have a blower door lying around, but if you wanted to do a cool little exercise to find drafts in your home, what you can do is shut all the doors and windows and then switch on all of your extractor fans, so your kitchen exhaust hood and your bathroom fans, and that'll start sucking air out of the house. And then you can go around kind of room by room and just start to feel where that air is getting made up. If you have a really big home that's really drafty, sometimes this isn't that effective, but we've tried it in a bunch of different places, and usually, yeah, it does work fairly well. And I think it's a fun kind of exercise you can do, going around as a bit of a draft sleuth, trying to find where it's all coming from. You could even kind of, get like a tissue or something to see if you want to visually see that how it's going to move a light material and detect the drafts that way. But yeah, cool little option. Switch all the fans on, shut the house up, and go room by room and see what you can feel. Also, if your house is really big, you could try to compartmentalize it a bit. So if you switch all the fans on and maybe shut all the bedrooms at the front of the house while you do the back of the house, and then vice versa, as you kind of compartmentalize the space, it can be a bit more effective. So that's a cool way to find drafts in your home. There are a few kind of classic areas and things you want to look out for. So doors and windows are a pretty obvious one. A less obvious one maybe is plumbing fittings. So often if these aren't sealed up properly, we get a lot of draft through those. Extractor fans are a big one. So I'll talk about this a little bit more once we've gone through this list. But if you imagine an extractor fan when it's not running in the bathroom or whatever, then it's just a big hole into your ceiling space. So which is not ideal and another source of draft, especially as our ceiling cavity gets hot. If you have an old fireplace or chimney that you don't use, that's probably the biggest source of air leakage in the home because it's just a giant chute to the outside. Evaporative cooling vents, when we're not using them, can be a source of draft, particularly because we have that connection to the outside air for evap cooling. Permanent wall vents, so the little kind of like slots in the wall in old style homes. These are sort of a bit of a relic that's left over from when people had open fireplaces or kerosene or gas heaters that weren't closed fluid. And so there's that risk or perceived risk of asphyxiation. Typically, you won't see them in modern homes. And if you don't have that type of heating system anymore, generally you can close these up as they're just a source of unwanted air leakage. Skirting is a good place to look. Ducted heating vents. So if you've got those ducted heating vents on the floor, if you take the cover off, 9 times out of 10 when we do it during an audit, you can see straight through to the dirt. So that's a cool one to check out, and a little bit of cork with get the caulking gun out can seal that up nicely. Floorboards, a good one to look out for. Also unused power outlets. So you've got a little power socket that's not being used. If you think about that, it's actually just 3 holes straight into your wall space. Wall space is not a conditioned area, so we want to keep that separate from our living spaces. So just a little like child safety outlet cover on the ones you're not using. Not going to be a bigger source of air leakage, but it's such an easy win. We always recommend that. So doubling back to extractor fans, I just wanted to point out one of the things that we typically use that I feel most people don't know about is these draft stoppers. You can just pick them up from Bunnings or online. And the way it works really is we get this, and maybe I'll stop sharing my screen for a sec so my camera gets big. So we've got this thing, and this goes inside the ceiling over the top of the extractor fan. It's got a couple of flaps, so when the fan is operating, it's just going to push those open and the fan can operate as normal, so that just goes straight through. And then when the fan isn't running, the weight of the flaps closes them, and so it's not perfectly airtight, but it's certainly going to be better than a big kind of hole into the ceiling space when the fans aren't running. It may be demonstrated a little clearer on the packaging here, but you can see how they sit in the ceiling there, and then when the fans are running, they can operate normally. And when they're not, you're not getting all of that unwanted air movement. The only trouble you might run into with these is with some of the built up kind of bathroom units that have the heat lamps and stuff, they don't really work because they just look a little bit different in the ceiling than a standalone extractor fan. Or if you have a very old fan that isn't particularly strong, sometimes even they'll just struggle to lift up these flaps and then you can't use it. But mostly you won't run into that problem, but we have had it a couple of times, so we weren't able to install it. And then the other one I wanted to chat about was fireplaces and chimneys, as it's one of the worst ones and a fairly common one. We used to go with the chimney balloons. Some people may have heard of them, some people might not have, but essentially the way these work is you put it inside the throat of the chimney and then you inflate it, and then that pressure will hold the balloon inside the chimney and stop drafts moving through it. We have kind of run into a little bit of trouble with these every now and then. When it cools down, they lose a bit of air pressure and they can fall out, or they might just leak a little bit over time. It's not a bad solution, but we've sort of moved on from these now, and we've started just installing medium density rubber foam inside the chimney. So you can get these. This is one we bought from EcoMaster, but you can also just buy medium density rubber foam from Clark Rubber, a bit cheaper. And then you just cut this to size or a little bit larger than the throat of the chimney. And then you stick it up, and that pressure, it's nice and squishy and strong and durable, and it'll just stay in there and stop air movement and stop unwanted draft coming in through an unused chimney or fireplace. So a good one for renters as well, because you could always pull it out when you leave, or talk to the next tenant or the landlord if they're not going to use it. So yeah, that's just a couple of little kind of products and stuff that I feel most people probably aren't aware of, that I reckon is pretty handy and we typically install. So I thought I would raise those. That more or less concludes our presentation today. And we can move on to a bit of a Q&A if people had any queries about any of the topics or anything else.